Hi guys, today we're going to be looking at a question on vertical motion. Stone A is thrown vertically upwards at a speed of 10 meters per second from the edge of the roof of a 40-meter high building as shown in the diagram below. Ignore the effects of air friction. Take the ground as reference. Question 3.1. Determine the term freefall. Freefall is when the only force acting on an object is gravity. Question 3.2. Calculate the maximum height above the ground reached by stone A. In order to calculate the maximum height, we can use the equation Vf squared is equal to Vi squared plus 2a delta x. Or you could say delta y, whichever variable you want to use. We then know at the maximum height, the final velocity is 0, the initial velocity being 10 plus 2, a being negative 9,8, and delta x. And we rearrange and solve, we get delta x to equal 5.10 meters. And since it says height above the ground, we need to add the height of the building. So total height equals 40 plus, this is supposed to be a 5, plus 5.10. And we get 45.10 meters above the ground. Question 3.3. Write down the magnitude and direction of the acceleration of stone A at its maximum height. So at its maximum height, the acceleration will be 9.8 as the only force acting on it is gravity, and this will be in the downwards direction. Stone B is dropped from rest from the edge of the roof, X seconds after stone A was thrown upwards. Question 3.4. Stone A passes stone B when the two stones are 29.74 meters above the ground. Calculate the value of x. So, in order to calculate that, we can start with stone A, and we can say, we want the time taken after x seconds when the stone has reached this height above the ground. Therefore, the height we want to know is 40 meters, so the total minus 29.74, which is 10.26. So that's the height we want to know how long it took to get there. So we can say delta x is equal to Vi delta t plus a half a delta t squared. And we can plug in our values. And when we put all of this into the calculator and solve, we should get delta t is equal to 2.79 seconds. We can then move on to stone B. And we want to know how long it took stone B to get to the same height. So we can say, using this equation as well, the same equation, we can say that negative 10.26 being the height is equal to the initial velocity, which we know is 0 as it was dropped, times delta t. And when we solve for delta t, we should get 1.45 seconds. We then take our 2 times and we minus 1.45 from 2.79 to get x. And we get x to equal 1.34 seconds. Question 3.5. The graph of position versus time for part of the motion of the both stones are shown below. Which of the labels A to H on the graphs above represent each of the following? Question 3.5.1. The time at which stone A has a positive velocity. When stone A has a positive velocity, we know that this curve is stone A, firstly. Stone A has a positive velocity at time d, as at E it has no velocity, and at F and G it has a negative velocity. Therefore, at D it has a positive velocity. Question 3.5.2. The maximum height reached by stone A. The maximum height reached by stone A, therefore on the y-axis, we can see is A, as this is the maximum height where the graph turns. Question 3.5.3. The time when stone B was dropped. Stone B was dropped over here, and that's the time F, corresponding to the x-axis. Question 3.5.4. The height at which the stones pass each other. So we can see, here's where the two stones pass each other. Therefore, the height that corresponds with it is C. And that's all for this video. Thank you.